Briony here from Kit Guru, and I'm here at Overclockers UK with 8pack, and today we're going to be doing a little bit of overclocking together. I've done a little bit of overclocking myself, probably once or twice, and it didn't really go my way. So 8pack's going to teach me how to do it properly, and hopefully you guys at home can learn something as well. So what is overclocking, and what are the sort of benefits and maybe negatives of overclocking?
Well, overclocking essentially is running the system out of spec to gain performance boost for free, essentially. So you can overclock all the buses on your PC pretty much. So you can overclock the CPU frequency, the cache frequency of the CPU, and the memory of the CPU. And then on the GPU, you can also overclock the core of the GPU and the memory of the GPU. And all these things combined, free performance, if you like, and can boost your system performance essentially by the percentage that you overclock. And obviously, what I call efficiency, the clock per clock performance is better as well if you increase the cache and the memory speed. So those are the benefits of overclocking. So you get higher frame rates in your games, faster rendering, and faster benchmark scores. Indeed, if you're a benchmarker, if you're a stock markets trader, it gives you better tick for trade. If you're VFX, better rendering times, and so on and so on. So everything you can do with your PC. If you like, the bar's raised by overclocking. The whole performance is raised.
So it's almost like a free performance boost. But what would you say are probably some of the negatives of overclocking? Are there any dangers for people to think about before they start overclocking their own system?
Well, I mean, if you keep within what we call safe parameters, overclocking's really quite safe. In all honesty, here at us UK, certainly since I've been here, we've been doing some very high-end overclocks on 4 or 5 generations of CPU where we've included delidding and all kinds of crazy modifications. And all that time we've been monitoring the RMA rate and the problems with the overclock system versus the stock system. And we've noticed no statistical difference there where the RMAs have gone up or the damage to components have gone up over that 5-year time while I've been here. So I mean, obviously we're keeping within safe parameters, using appropriate levels of cooling and our own experience to do this. But given those parameters, I myself, and actually across Casking Group, they've also been doing this in Germany, and I've been collating with my colleague Roman Hartung, who's also a professional overclocker, if you like, also known as Debar, and he's noticed no change in RMA rates either. So it's if you're sensible about it, you read around it or follow a guide made by someone who has proven track record, then I think you're fine.
Yeah, so for someone like me, I find it quite sort of scary because I don't really know what I'm doing. But hopefully in this video, you're going to take us through the BIOS and show us that maybe it's a lot easier than a lot of people think. And when you're going to explain to us sort of what everything means, and that even people that are quite new to having their own PC and things, they can get that free performance boost rather than having to pay to upgrade parts. So if someone's looking to build a PC or buy parts to overclock, what would you say is important when people are looking at cooling and maybe like the motherboard and things they choose? What is the best things to look out for?
Well, first, obviously, they have to, if they want to overclock the CPU, then they have to buy a CPU that is overclockable. So they need to buy like a K-SKU CPU or an X or XE suffix CPU. The CPUs that don't include the suffix 6 no longer can be overclocked. In the past, there's been FSB overclocking that allows a non-K-SKU to be overclocked, but the latest, like Gen 8, Gen 7, cannot be overclocked in that manner. So you have to, if you want to get that free performance boost, you have to get a CPU that's overclockable. So that's the first thing. Yeah. Then if you're looking at motherboards, you have to get like a Z370 on the mainstream platform or X299 on the Extreme platform, because these allow the overclocking adjustments that you want to make. Within the motherboard itself, you should be looking for a motherboard with high quality VRM, so it can supply good quality power to the CPU, because obviously as you're overclocking, you're speeding things up, the power draw that the CPU needs is greater, therefore it puts demand on the VRM. So Often this is always covered by the mid to high end boards, but sometimes by reading around reviews or what other people are doing on the internet, you can find a lower spec board, if you like, with a really good VRM that can also overclock pretty well. So that's something else that I'd be looking for, a good a K suffix or X suffix CPU, then Z370 chipset if I'm doing 8th gen, with a good VRM and some good features, that I might also want to take use, because if you're thinking about overclocking, you're obviously fairly serious about your PC, so you might want a decent audio on there, for example, NVMe support and so on and so on. So look for those other features, and then often the overclocking is also well built into it,
Yeah.
Then once you've got then how far you can push the CPU is often dependent on cooling, because as you overclock the CPU, you raise the voltage on the CPU to keep it stable. And raising the voltage produces extra heat. Now this heat you have to remove, or the CPU becomes unstable, or the component you're overclocking becomes unstable. So obviously you might want to add some aftermarket cooler, like either a big air heat sink or indeed an AIO, depending on what your ultimate goal is. I mean, some people go for very high custom air water cooling, but for very simple overclocking, you just need a really good air cooler.
Yeah, so you could almost use the stock cooler, but if you want to get more clocking potential out of your CPU, then it is worth investing in a better cooler, you would say.
Well, I mean, Intel, there's no longer a stock cooler, they don't, because they know that people with the K XAX suffix CPUs want to overclock, so they'll just leave it to the customer to choose. And obviously you can choose suitably by reading through the reviews and checking which cooler is best for your CPU. Because obviously a 6-core 12-thread CPU, for example, doesn't need as much cooling as an 18-core 36-thread CPU when you're trying to overclock it. The TDP on both CPUs is massively different, the heat output's massively different. So you can check the reviews and then choose an appropriate cooler. I mean, in my own bundles that I do here, the minimum cooling is like a 240 all-in-one cooler with like 1,000 RPM fans, because I like to keep the system really quiet also. Yeah. And with that kind of cooling, you can run like an 8700K at like 5.2 once you've delidded it. But I mean, even cheaper air coolings like the Brocken 3 or something like that, you can easily run like 4.8 or 4.9 on an 8700K, for example, or an 8600.
So that's a really big difference in sort of the performance you're going to get from that CPU, just from something that like a free overclock and just some half sort of decent cooling. You can get quite a big performance increase. Yeah,
I mean, nowadays, because the TDP of the CPUs are much higher than they used to be, what you'd traditionally call the Intel stock cooler would not cool these CPUs anyway. That's why Intel do not do one. So you have to buy an aftermarket cooler anyway. So you may as well spend like £30 as opposed to 15 or 20 and get a cooler where you can gain, maybe 20% performance. You may as well. And obviously these aftermarket coolers are designed to not only keep the CPU cool, but also be quiet. They've got PWM fans which you can attach to the motherboard that are very silent when the CPU's not been pushed, but when the CPU has been pushed, they spin up a little bit quicker. But then often if you're a game, you've got the headphones on anyway, so it's not going to make any difference to the quality of your gaming session.
Okay, so how would something like RAM as well, how would that affect the overclock that you can get out of your CPU?
Well, I mean, there's a balance with RAM speed in terms of my own testing, as how much it improves the performance of the system. I mean, if you're running memory at above like 3600, for example, this usually hits the overall overclock that the CPU can do, because the CPU and the IMC are working very hard already to supply the memory, if you like. So I'd suggest really for normal overclocking, but you still want a benefit from the memory, like 3000 to 3200 is the sweet spot. I found in my testing that because of the changes in cache latency as you go up, 3600 is absolutely the definitive point where you're getting very small boosts from going higher, but then the CPU overclock may well have to come down, or you have to apply other voltages to the system that add heat, which you don't want to do when you're overclocking. Certainly not on a basic cooler anyway. So I'd suggest anyone who is overclocking, they want some more efficiency out of the system, more clock for clock performance, by overclocking the RAM, that they go for something in the 3200 mark. And obviously anything over 3600, 4000 is very expensive anyway. So this is aimed at like what anyone can do. So, you know, memory as it is now is expensive, but the really high-end memory is very, very expensive. So 3000, I think.
That's plenty for overclocking.
Yeah.
So now that we've covered sort of the overclocking basics and what to look for when you're choosing components and things to overclock, should we head into the BIOS and have a go, and you can show me what the process of overclocking is and how to then test the difference between what we've got now, like the stock clock, and then the sort of improvement you can get from overclocking.
Yeah, sure. I mean, I think this system, I've totally reset the BIOS, so we're running at stock now. I mean, I think it is important for the viewers to know that stock is actually overclocked, because Intel Turbo Boost is not the stock clock. Like the stock clock of the 8600K that we'll be overclocking here is actually 3.6 gigahertz. But when you put load on the CPU, it's automatically overclocking to like 4.2, 4.3, depending on the load anyway. So Intel have already built some overclocking into within the spec of the CPU, and we should point that out to the viewers so they know that their CPU, even at stock, is overclocked, essentially. Yeah. What I'll do now is just show you the stock Cinebench score, if you like. Cinebench is a rendering benchmark, but you can from it you can quickly see the performance of the CPU, and then obviously we can see the impact of the overclocking.
Yeah, it'd be good to have a look and see what we've got at the moment, and then how much extra power we can get from overclocking the CPU.
So I'm just going to overclock open CPUz here. A couple of tabs just so you can see what's going on. Here obviously we've obviously got the core speed of the CPU, the voltage being applied, the size of the memory, the cache frequency, and the memory frequency. So you'll see the core speed going up and down here simply because obviously the CPU, when it's not under load, steps down. And when we open Cinebench and run the benchmark, then we'll see that it goes up to 4.1, 4.2. Okay, the same here, the cache is fluctuating because it's stepping down, and the memory frequency, this is stuck at 2133, which is what the default, if you like, the default memory speed that DDR4 always boots up with. In the profession we call it JDEC, but you don't really need to know that. It's just a frequency for the purpose of this demonstration. So once we've opened that, we can open Cinebench up. Just accept the licensing agreement there and run, and we'll see it quickly renders the page. Here we've got obviously 6 cores, 6 threads, so no HT. HT does actually help with this benchmark, but for gaming it's not affecting at all. And we can see obviously the CPU's turboed now up to 4.1, and the cache frequency is turboed up to 3.8.
And that does that by stock without any, say if I was to use this PC without me going to the BIOS or anything, that the CPU would do that by
stock.
Absolutely,
by stock, yeah.
Oh, it's nearly done.
Yeah. So we've got a score of 1003 points. Yeah. Okay, so now we'll just make a few adjustments in the BIOS and then see what our score is. And we'll also quickly talk through how we can make sure that the overclock that we've done is working fine.
Yeah.
Okay. So, we'll see.
So you might be able to push a CPU to the limit, but if it's not stable, then it's not something
that's
you want.
pointless. You don't want to crashing out of your games. You know, you're in the middle of a game, you're just about to win, and then the whole thing crashes. I mean, that's going to cause you more anguish than it will, happiness at getting free performance out of the system.
So stability testing is quite an important part of overclocking.
It's certainly an integral part, yeah. On reboot, we just hit the delete key and we come into the BIOS. The BIOS is basically how or what parameters the PC boots with, and also checks, what's plugged in to the system itself, like an initialization, if you like. So from the BIOS, we can tell the system to boot up with different parameters, essentially. Yeah. And here we're going to tell it to boot up with overclocked ones. So this CPU here is an 8600K, and from experience I know that all of them can do like 4.8 on the CPU core. Yeah. On the cache they can all do like 4.2, and then with our memory we're just going to set XMP, which is the Intel Extreme Memory Profile. So that automatically overclocks, so you don't have to worry about anything else. You just set XMP, and providing the motherboard is compatible with that memory, it'll just overclock it automatically.
Because often when you buy like 3000 megahertz RAM, it might come as at 2133, and then you have to enable XMP in the BIOS.
Yeah, that's the only way to do it, because they all boot up at 2133 initially. And then you enable the XMP, which tells the motherboard, if you like, the parameters to apply to the entire timings of the memory, which we discussed earlier, such as cache latency, and then the memory can operate at a much higher frequency.
So even if someone isn't looking to overclock their CPU, that they should always go into the BIOS and enable XMP.
Yeah, because they've already paid for that performance. You know, they've paid for 3000 megahertz memory, and the system will always boot at 2133 until they've enabled XMP or put in the settings manually. But why do it manually when you can just enable one setting? So from here, we're going to just try to do the overclocking in 4 or 5 settings. So initially, we're going to change the CPU clock ratio.
And would that be called the same thing on like most BIOSes? They've got the same name, because I know some between different manufacturers it can vary slightly.
On all the manufacturers, it's called CPU ratio. Yeah. So for 4.8, we're going to type in 48 here to give us 48 times 100. 100 is, as you can see here, the CPU base clock. So 48 times 100, 4.8 gigahertz. Now we're just going to go down to the XMP and enable it. Okay, and as you can see, now it's going to enable our 3000 megahertz memory here. Into advanced core settings, set our UnCore ratio.
And what is the UnCore ratio?
This is the cache ratio. So the level 3 cache and so on is running at that speed, and it obviously helps with memory bandwidth and CPU efficiency. Like 3 core ratios is effectively equal to 1 CPU ratio. So if you want to extract absolutely everything out of your system, which we're not actually trying to do here, I'm not really pushing that hard. I know that maybe this can go to 4.6, 4.8 sometimes even. I'm just doing something that every CPU can go to, so the viewers can just gain a little bit of extra performance. So I'm going to put in 42 there. And the last couple of things we're going to put in are the voltages. So under CPU core voltages, we're going to put in 1.3. Which is about the maximum you can use on this type of cooling. So
that would be safe for this particular processor with, like, is it an air cooler in here?
It's a 240 IO, but a good air cooler can also, 1.3 under load is also fine. And then I'm going to adjust something known as the LLC, or load line calibration. Now this makes sure basically that under load the CPU voltage does not drop. If the CPU voltage drops, then you get instability. So whatever I've just plugged in on the last screen, 1.3 is kept no matter what load. If you don't enable LLC, Intel's, if you like, graph of voltages, the more load, the less voltage it applies essentially. So you get what's called V droop, or a drop in the core voltage. So here we're going to make sure the voltage stays exactly what we've entered. And to do that, I'm going to choose turbo. Now there's one higher setting, but that extreme usually means that it goes up under load. Well, we don't want that either, adding extra heat and possibly causing instability that way. So I think for all manufacturers, do not apply the highest LLC or load line value that you can. Apply 1 or 2 levels less. Then when you go into Windows, check what the voltage is. Is it what I typed in? If it is, fine. That's exactly the right level to apply. And
that's sort of the low line calibration, you can use that on all CPUs. So even though like the voltages and things we've just done were specific to the 8700K, the low line calibration, you can use that on any CPU.
The low line calibration and the XMP setting can be used on any CPU,
And if someone, say for me, I've got a 7700K, so where do you think would be the best way to sort of find out what voltage would be safe? And what's the best way of sort of trial and error and sort of testing to see what voltages and things I can use on my particular CPU?
Well, I mean, you can test that in Windows by running some kind of appropriate stress program and checking the temperatures given by a certain voltage and overclock. You know, if temperatures are certainly above the mid 80s, pushing towards 90, then that's too much. So you just need to back off the voltage a slight bit there. But I mean, with experience, I know that like for this CPU 1.3, for your 7700K on on mid to low end cooling 1.275, on higher end cooling 1.3, on full water cooling 1.35. You know, I know this from experience, but yeah, you do have to build up that experience, otherwise you have to check like I've just described.
So most CPUs are sort of around that like 1.2, 1.3 mark is going to be safe, so you're not going to fry your CPU.
No CPU will die at 1.3.
Oh, okay,
no chance. Or even degrade, no chance. But it's better that you do actually always check the temperatures, you know, once you've booted into Windows. Because also obviously you want to check as well that your heat sink's mounted well and you're getting the most efficient transfer, and you can quickly see that if you put a stress program on and the temperatures are way too high, you're like, you know, with a sensible voltage, then you know that maybe you have to remount the cooler. And that can happen with stock systems, you know, you may have to remount the cooler then as well if you haven't got quite the thermal paste in the right position or the pressure or correct on the CPU.
So often overclocking can almost find out problems that you might not have noticed before.
Yeah, for sure. Okay, so we've enabled our load line, and that's essentially it. If we want to save that as a profile, so where we can load up earlier, we just go to like save profiles and then give it a name and so on, and you can reload the profile here. But I mean, there's no need for that right now. I mean, I know this is going to be fine. So just to save and exit, we can choose this option here, or I always, on every BIOS, you just hit F10, hit enter, and then the system will reboot, but this time with the new overclock parameters.
So if someone went to boot and then it didn't boot first time because they pushed it that little bit too far, what would be sort of the first step if you noticed that it crashed as soon as it started to boot?
The first step for me would be to go back to default, and then try initially just with XMP and test, is that working fine? Once you've tested that, then test just overclocking the core, one ratio at a time.
Is that without changing the voltage at all, just sort of?
No, just stick with your 1.3 voltage or what voltage you've discovered is safe, and then one ratio at a time, and then the same with the cache, one ratio at a time, just to check.
So it can be a little bit time consuming, but it does allow you to get that extra performance.
I mean, what we're doing here for the 8600K, everyone can do in like five inputs. It's just if you want to get the last 2, 3, 5% that your CPU is able to do, and obviously not every CPU can reach the same height. So if you want to find out what the total height is, then you have to spend a lot of time, you know, plugging in a lot of different values. Okay, so now we've booted into Windows, let's check that our overclock's taken to the system, and also that our scores improved appropriately. So we'll just open CPUz. This is a piece of software, like I said before, that's reading all the frequencies, and now you can see we're at 4.8. Let's also check our memory and cache speed. So our cache speed's at 4.2, and our memory speed is 1500 here, but remember it's DDR, so dual data rates. So you have to double this value to get the effective actual memory speed, so that's 3000.
It's a don't panic moment if you...
Yeah, exactly. I mean, if you've enabled XMP, this is normally going to be fine, but you should always check. So we've got Cinebench open here, and we can see our score from before highlighted here, 1003. So let's run again. And if we notice now also this time, we can check on CPUz here, our core voltage with the LLC applied is almost exactly 1.3 all the time. Now when we ran this test before, it started off at 1.3, but it dropped to 1.21 under load because we'd not applied any load line calibration. Now we've applied that, it's sticking it to exactly what we applied in the BIOS.
So it's making sure the processor's got enough power to maintain that clock.
To maintain stability whilst at that clock frequency, So we'll just quickly run through the bench here. So now we're at 1,168 points. So I mean, this is this is actually really convenient that the other score was nearly 1,000, and now and this is up because we can see we've improved the system by 16.8% in like a matter of 5 settings there. Now obviously you need to do more. Now you can obviously see immediately from choosing any benchmark, and there's a wide range, like FutureMark 3D type benchmarking, or maybe TerraGen, or RealBench, or any of these programs. You can see immediately, my overclocks worked. But what you want to know is that when you're playing a game, or when you're doing some of your rendering or some work that you're going to do on the PC in every day, that it's not going to crash or you're not going to have any problems. Now obviously there's a wide range of stability testing programs that you can use to check this. And I think the best way to actually test is obviously to use the PC long term.
Yeah.
But for most users, they don't want to do that in case they're doing something long term and it crashes.
Yeah.
So let's just suggest a couple of maybe 2 or 3 stability programs that the end user could run for maybe an hour just to check that what they've done is going to be okay in 99% of situations.
Yeah.
So for that type of testing, I like something like Realbench that we've got installed here.
Yep.
So we'll just run this quickly for a few seconds and also point out to the end user what they should be looking at in terms of temperatures.
And is this program like a free one that everyone can download?
It's a free download off the Asus ROG site.
Yeah.
If you just type in Realbench, and they keep it up to date with the latest hardware. This is version 2.43.
Yeah.
It's been through several revisions, so it can detect what hardware you've got in the system and so on and so on. You can see there's a stress testing tab here, so you can just click this. The amount of time you want to stress test for, I'd suggest that 1 hour really with this is fine, but I'll just put 15 minutes. I mean, obviously we won't even do that. You can test the full amount of RAM in the system, which in this case is 16 gig, and just hit start. Before we do that, I'm going to pull up Core Temp here. This is a program that reads the temperature of the CPU. And as we said when we were discussing earlier, we want to make sure that our max CPU under full load is ideally no more than mid-80s, certainly not into the 90s. Yeah. So we can check that whilst the program's running. And I also like Realbench because it's actually doing encoding on the CPU, which is a real life thing, and it's also doing rendering on the GPU, which is a real life thing. So it's very not so synthetic, if you like, as some benchmarks are. And also I like it because it's stressing the memory out, it's stressing the CPU core out, and it's stressing out the PCI Express lanes, which are controlled from the CPU on the GPU. So it's testing out everything, or all the buses across the system. So that's why I like it really, because it's very similar to real life. So we hit start and we see it's running away. We can see immediately the processor's at 100% load.
Still very quiet, this PC.
Yeah, I mean the fans are around 1,000 RPM. We keep when we're specing systems, we keep that in mind all the time, that it's not going to bother anyone on the desk or interrupt the gaming sessions.
So effectively, we've pushed the CPU a little bit, but it could probably go a lot further.
Yeah, I mean, you can see from the temperatures here, like they're maxed out at the moment around 60. Now, obviously, you need to leave it running for around an hour or so that the heatsink becomes saturated, and you can find out really what the actual temperatures are if you're gaming for 1 hour, 2 hours, or this kind of thing. You don't want to just leave it 10 seconds, oh yeah, it's fine. Maybe 1 hour of this kind of load will saturate the heatsink, so you know. I mean, for example, I quickly did this yesterday in a similar ambient temperature room, and I found out my temperatures were about 78, 79, so well within tolerance. But obviously for our viewers, I want to make sure that we're doing something that they can all do without being on the edge of temperature, without really having to worry about such things.
I expect a lot of people will probably be investing in this new Coffee Lake CPU, and they want to get a safe clock that's not going to cause too much damage, and now they know like a safe voltage and a safe clock that they should be able to push it to.
1.3, 4.8, 4.2 XMP. That's all they need to set. So Realbench is one example of stability testing. I'm just going to stop that now. It takes a couple of seconds to stop. And then other like more traditional examples are like Prime 95, which we've got here. And I tend to run Blend because that tests, again, the Blend is doing some small FFTs, some large FFTs. The large ones are running in the memory more, the small ones are running in the CPU core and cache. So I tend to do a Blend for like 45 minutes or 1 hour again. Now this version of Prime is version 26.6, which is the one without AVX instruction. Now AVX instruction is running the CPU very, very hard, but no games has that. So for the gamer, you do not need to use AVX instruction, so it's fine to use 26.6. And again, you'll see the temperatures, peaking mid to late 60s. Again, when this goes to small FFTs, though, they'll be touching around the 80 mark. So, in my experience, maybe 1 hour of this and 1 hour of Realbench, for example, then just use your PC as normal. If you're doing counter instability then, and you wish to put that right, just knock down the multiplier of the CPU core by 1, check again. But for 99% of users, especially those who are not using AVX, then this is completely fine. If you are using AVX, there is actually a little setting in the BIOS that's AVX offset. Now, if you set that to a value of 2 or 3, 3 is 100% for sure, 2 in 99% of cases when AVX code is fine, it just automatically detects AVX code and clocks the CPU down by 2 ratio. So for this CPU, it'd be down to 4.6. If you set 3, it'd be down to 4.5. So if we ran AVX prime, it'd be running at 4.5 with the 3 or 4.6 with the 2, just so that for that extra incredibly hard work, if you like, that AVX2 or AVX512 puts on the system, the CPU is protected more, so it clocks it down a little bit more and you remain your stability. But for the gamer, that's not really necessary. But for the professional who's maybe got programs now that are introducing AVX because they know that, like, AVX2 you can gain like 10 or 15%, AVX512 you can gain up to 30%. A professional software writer would now maybe code with that. So if you are using your system for multiple things, quickly set that AVX offset to 2 or 3. And you've still got this stability testing, then you know it's completely fine.
Most motherboards will have that in the BIOS.
Every single one. Every single Z. Yeah. Every single Z or X chipset has that, yeah. Because Intel themselves know that a customer will want to tune their system to be efficient over every possible workload. Yeah. And for example, sometimes on X we have three offsets. So you have the non-AVX at all, you have the AVX2, and then you have the AVX512. So AVX512, that you might have to set 5 ratios less for AVX512 load, but it's 30% more efficient, you know. Whereas AVX2 you'll probably have to set 2 or 3, and then non-AVX none. So on the X chipset you can have 3 ratios, and it's happy to run at those 3 different speeds.
But for most people, they don't need to worry.
No, they don't need to worry. I'm just discussing that just in case the professional thinks, oh, I'll just quickly overclock my system, and then it crashes. Then probably the reason it's crashed in a professional environment is the software that they're using is AVX. So in which case, just quickly plug in 2 or 3 to that number, probably 3 to be 100% safe, and then you're all right with this type of stability testing. If you want, you can update to the latest version of Prime, which does have AVX2, and maybe run that for 30 minutes or whatever, and check that your AVX offset is indeed kicking in, because you'll see here on CPUz it's clocking down, and that again everything is fine. Yeah,
so you can always have one clock for when you're gaming and then one clock for when you're
working. Exactly that, yeah. And you don't have to reboot, you know, go into the BIOS down. It does it automatically, and the response of the CPU to clock down is like instantaneous. So as soon as it detects AVX, it clocks immediately down. But still, obviously, we're above stock because we discussed our stock speed was like 4.2. Well, our stock speed 3.6, but our turbo is like 4.1, 4.2 on this CPU. So even with the 3 offset, you're at 4.5 instead of 4.1. So you're still getting 10% rather than our 16.8%. You're still getting 10%. And for the professionals rendering, that's 10% of saved time they can render the next thing. So even with the offset, they've still got a boost in performance.
Okay, well, thank you very much. I feel like I've definitely learnt a lot today, and I feel much more confident about going home and trying it out on my own CPU. I sort of know what everything sort of means now, and when I am changing the voltage and things, not to be too scared, because for 1.2, 1.3 will be safe for most CPUs.
Yeah, it's absolutely fine. I mean, what we've covered here, it's just literally set the ratio, set the cache ratio XMP, set the voltage of the CPU, and set your load line calibration to keep that voltage consistent once you're loading it in Windows. F10 and go.
And then check the temperatures and then do some stress testing as well.
Absolutely. Yeah. And the best stress testing is you using the PC. Yeah. Don't get too hung up about running these for hours and hours and hours and hours. Yeah. 1 hour or 30 minutes of a couple of different stress tests, it's in 90% plus application, it'll be fine. Let's get on with gaming. If I have a slight issue, I'll just move the ratio back 1, and I've still got a good boost to performance, and I've not got to worry about the stability.
Okay, thank you very much. This has been Briony for Kit Guru and 8-Pack for Overclockers. Thank you very much for watching. If you like this video, give it a thumbs up, and if you'd like to see more from Kit Guru and Overclockers, please hit the subscribe button.
VRM is voltage regulator module. FSB is front-sided bus. RAM's random access memory. CAS is one of the memory timings that if you enter lower value gives you more efficiency. If you enter a higher value, essentially in the BIOS, it gives you less efficiency. Obviously, the less efficiency value gives you more stability. Buses, several buses on the system. For example, the PCI Express link to the CPU, the NVMe link to the PCH or the CPU, the memory link to the CPU, the internal link between the core and the cache, or the cache and the IMC, and so on and so on. IMC is integrated memory controller. This is controlling the dual channel memory on this motherboard, or the quad channel memory on X299.
Woo!
Ah.